All right, so we need to choose a sign convention for our problem, and I'm just going to go ahead and choose this way as positive. As we said in our previous example, once that's chosen, we need to figure out which forces line up with positive motion and which with negative. So for mass 1, it's a negative force. It actually fights this direction that we're calling positive. W1 is a positive force. This tension is a positive force, and this component of weight is a negative force. Again, we're defining positive motion as both M1 falls and M2 rises up the plane. If anything fights that, it's considered a negative force. If anything helps that, it's considered a positive force. If that's not clear, please make a little bit of time to come and see me to talk that out. So let's set up equations for M1 right here. Oops. For M1, we're going to actually have T minus W1 equals M1 times its acceleration. And when we plug in what we know, we're going to have T minus, and do I have that right? I don't. See, I wrote my sign convention down, and I actually got it backwards. So we're going to have W1 minus T equals M1 times A. And let's actually plug in what we know. We have M1 times G minus the tension equals M1 times A, which we'll write right here. Now, for the second mass, let's go ahead and write its equations down. We actually have two equations that we need to write for it. The first is that we have a tug of war with W cosine theta and N2, and the effect is that both of those cancel. So we do in fact get the true but not necessarily useful answer that the normal force is actually equal to part of the weight right here. We're going to set that aside. Now, the second equation that actually matters is that we have the tension having a tug of war with part of the weight, which is M2g sine theta, and the effect is that M2 actually accelerates. So now we can do a little bit of substitution to go ahead and solve our problem. So let me just rearrange here. I'm going to say that the tension is M1G minus M1 times A. And so I can go ahead and substitute that into this formula here. And when I do that, I'm going to get M1G minus M1A minus M2G sine theta equals M2 times A. And I'm just going to do a little bit more math here and go ahead and solve. So I'm feeling not ambitious right now. And I have some yogurt in the fridge that I want to eat, so I'm going to finish this video with M1G minus M2G sine theta equals M1 plus M2 times A. When we solve for A, we're actually going to end up getting that M1G minus M2G sine theta over M1 plus M2 is our acceleration. The short answer then is that we can plug this A into the formula here, and when we actually do that, what we're going to end up getting for our tension when you solve is we're going to get something along the lines that tension equals M1 M2G over M1 plus M2 times 1 plus the sine of theta, if I've done my math correctly. I'm going to actually let you go ahead and verify that on your own. But that's the solution to this particular equation.